Okay, so last video on section 6.2, an interesting feature of inverse functions is that for all inverses, f and f inverse, the compositions f of f inverse and f inverse of f will equal x. We actually saw this at the end of section 6.1, I'm sorry, where when you took two functions and compose them, you get the function x back out. And if you interchange those, you got the same thing. One of the examples I showed you was the function f of x equals 1 over x plus 1, and the other function was now I used g of x at the time, but it turns out it's the inverse, so I'll use f inverse. 1 minus x over x. And it turns out when you compose these two functions, the answer, the new function when you simplify it, is just x. Right? So we saw this in the last section, that f of f inverse is equal to dot 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 x, and when you compose them the other way, I think I only did one way, but the other one also works. If you do f inverse of f of x, you eventually just get x again. Okay, that will always happen for inverses. I'll show you an example using one of the sets of functions that we dealt with earlier in this section. Let's take a look at f of x equaling 2x minus 5. And let's take a look at f inverse, which we found to be 1/2 x plus 5/2. Again, if I just compose those, I should, in theory, get x as the output. So let's take a look at that. Let's do f of f inverse of x first. And so in that one, the outer function is written first with an empty space for the x. The inner function gets filled in for the x, 1/2 x plus 5/2. When we distribute the 2, 2 times 1/2 is 1, and 2 times 5/2 is 5. Then I still have this minus 5. The two two 5s, the plus 5 minus 5, those add up to 0, and I'm simply left with x, 1x or x. Okay, so there we have it. And if I reverse the order, of course, it should work out the same, but just to prove it to you, we'll work it through. F inverse of f of x. Okay, f inverse is now the outer function, so I'm going to go with 1/2 x is the empty set of parentheses plus 5/2. Inside the parentheses goes the inner function, which is 2x minus 5. I then again distribute the half, and we will get, let's see, 1/2 times 2 is again 1x. 1/2 times negative 5 is minus 5/2. We still have the plus 5/2 hanging out. The minus 5/2 and the plus 5/2 add up to 0, and I am simply left with an x again. Okay, so either way you slice it, either order, the compositions will always equal x. This will happen every time you have inverses. Now there's a little bit to say about the fact that this only works on the domain of those functions. Some other maybe details that I'm not going to get into, but generally speaking, if you can get those compositions to equal x, then you know that the two functions you're looking at are inverses of each other.